Today we are going to discuss structure of alcohol and ether group. How is the structure of alcohol in ether group that we are going to learn today? You can see this structure. It is methanol CH3OH. In that, this one is our CH3, then O, then H. Now, as we know, this carbon is having sp3 hybridization. Same way in phenol, you can see benzene ring on that OH group is there, so it is phenol. Now in benzene ring, this carbon is having double bond on it, and that double bond resonates in it. So this carbon is sp2 hybridized, while in ether you can see CH3O CH3. All this carbon, these two carbons are having sp2 sp3 hybridization on it. Okay, sp3 hybridization on carbon. Now what about oxygen? What is the hybridization on oxygen? So in all these three structures, oxygen having single bond only. So hybridization is sp3 hybridization. And according to hybridization, the structure must be tetrahedral and bond angle between carbon, oxygen and hydrogen. This bond angle, carbon, oxygen and hydrogen. Similarly, carbon, oxygen, hydrogen. In this structure also carbon, oxygen and carbon. This bond angle, that must be 109.28 minutes. 109 degree 28 minutes. That is the standard bond angle in sp3 hybridization. But here what happens? You can see this structure. Oxygen is having two lone pairs of electron on it. So this lone pair of electron, it arranges themselves on the upper side of oxygen. So there will be repulsion between them. Between these non-bonding electrons, there will be repulsion. Due to that, what happens here? Look here very carefully. Suppose these two are our lone pairs of electron. These two pairs are lone pairs of electron. Now, due to repulsion, they both tend to go away from each other. So, they both will go away from each other. And due to that repulsion, this benzene ring and hydrogen, they will come near to each other. In this structure, you can see CH3 and H is there. These are lone pairs of electron. There will be repulsion between them. So, it goes away away from each other. So this CH3 and H, they will come together. They will come together. So the bond angle contracts here, and the bond angle becomes 108 degree 9 minutes in alcohol. Again, in alcohol the bond angle is 108 degree 9 minutes. Data is not important here. This value is not important, but the reason is important. Why the bond angle is not 109 degree 28 minutes and 108 degree 9 minutes is there? Why? The reason is very important here. Similarly, you can see in this structure, in phenol, this structure. This one is our benzene ring and this one is our hydrogen. Now benzene ring is quite bigger than this methyl group. Here you can see oxygen has one methyl group on one hand and hydrogen on one hand. Here a benzene ring is there. So it is quite bigger than methyl group. So what will happen here? Repulsion will be there between these two lone pairs of electron. You can see here. Repulsion will be there, but repulsion will be less. Why? Because in order to go away from each other, this benzene ring should move here. but it is quite bigger. So due to steric hindrance, it is not moving as much as methyl group. So bond angle contracts here, but not as much as alcohol. In phenol, the bond angle is 109 degree only. The difference between standard and this value, phenol bond angle value, is 28 minutes only. Okay. Now what happens in ether group? Now here oxygen has two methyl groups on it, not hydrogen, no hydrogen is there. Now what happens here? These two methyl groups are electron donating group. Again, methyl groups are electron donating group, so they have some extra electron density on it. So if they come together, there will be repulsion between them also, so they tend to go away from each other also. So what happens here? Here repulsion will be there, but between these two methyl group, not between these two lone pairs of electron, between these two methyl group, repulsion between them. So they will go away from each other. So here the repulsion is inverted. Between two methyl group repulsion is there. So bond angle increases. Instead of decreasing, the bond angle increases here, and bond angle becomes 111 degree 7 minutes. 111 degree 7 minutes. That is the bond angle point. Again, in alcohol group, repulsion is there between two lone pair of electron, non-bonding electrons. So due to that repulsion, the bond angle become 108 degree 9 minutes. Same way in phenol, repulsion is there between non-bonding electrons, but phenol benzene ring is quite bigger than methyl group, so repulsion is less. So bond angle becomes 109 degree. In ether group, repulsion is there, but between these two methyl group, both are electron donating group. So repulsion is inverted here. Between two methyl group, repulsion is there. So due to that, bond angle increases and becomes 111 degree 7 minutes. Now bond length. What is bond length? So distance between carbon and oxygen, that we are going to discuss here. In alcohol group, distance between carbon and oxygen, that is 146 picometer, but in phenol, the distance between carbon and oxygen, that is 136 picometer. Why it is less than alcohol? So we know that this non-bonding electron will take part in resonance structure. So it will make some partial double bond here. Resonance structure we have learned. So there is partial double bond here. Due to that partial double bond, this bond length decreases to 136 picometer. Now the next point, that is preparation of alcohol. Now preparation of alcohol, there are different methods to prepare alcohol. First method is from alkene. Alkene means double bond, hydrocarbon having double bond in it. So from alkene we are going to prepare alcohol. Suppose take this alkene. These two carbons are there, and between them a double bond is there. Two carbon means eth, plus double bond is there. So E and E suffix will be used here. So this is ethene. When we add H2O in it, if we add H2O, suppose I am adding hydrogen here and OH here on second number carbon, hydrogen on first number carbon, and OH on second number carbon, and double bond is breaking here, so we'll get alcohol. You can see this structure, CH3 CH2 OH, we'll get alcohol. But to break this water into hydrogen H plus and OH minus ion, we'll need acid. So it is acid catalyzed hydrolysis, or you can say hydration. Acid catalyzed hydration reaction. It is hydration reaction. Again, acid catalyzed hydration reaction. Now, if we break this alkene, we'll get two same parts, CH2 and CH2. So on whichever carbon you can add hydrogen and OH, that is okay. But if two parts are different, suppose I am taking this, you can see 1 2 3 4 carbons are there, so it is but on first number carbon. This is our first number carbon, a double bond is there, so but 1 in, this is but 1 in. When we add H2O in it in presence of acid, what will happen here? You have to remember the Markovnikov rule. What is the Markovnikov rule? So break this in two parts, H plus and OH minus ion. This OH minus ion will go on carbon that has less number of hydrogen. Again, negative part of reagent will go on carbon that has less number of hydrogen. Again, negative part of reagent will go on carbon that has less number of hydrogen. You can see these two carbons are having double bond in it, so we are going to add H plus and OH minus on these two carbons. Now where we are going to add OH minus ion and H plus, so minus ion will go on carbon that has less number of hydrogen. You can see this carbon is having 2 hydrogen, this carbon is having 1 hydrogen, so this carbon will get OH minus ion and this 1 number carbon will get H plus ion. So this will be our product. It is 1 2 3 4 but plus on second number carbon alcohol is there, so butane to all, that is our product. Now look at the mechanism. I am taking another example here. See, CH3CH double bond CH2, so it is propene. Okay, when we add H2O in it in presence of H plus, we'll get this product, propane to all. This is our product. Now what is the mechanism of this reaction? So what will happen here in mechanism? You can see step 1, we have taken H plus means acid and H2O. So what will happen here? Acid has tendency to donate H plus. Again, acid has tendency to donate H plus, so acid will donate H plus to H2O and H2O becomes H3O plus. That is our step 1. Now in step 2, what will happen here? This H3O plus will donate hydrogen H plus ion to alkene. We have taken propene, so this is our propene. This H3O plus will donate H plus ion to the alkene. So you can see H plus ion will go. Now H plus ion means it does not have any electron in it. So in order to make bond with alkene, it will take these bond electrons. So this double bond will break here. So you can see we can add H plus ion on to these two electrons, these two carbons, double bonded carbons. So suppose I am adding H plus to first number carbon, so we'll get this product. You can see double bond breaks here, CH3 CH bond, instead of CH2 here I have written CH3, and positive ion will be on adjacent carbon. So this is our 2 degree carbocation. Now suppose H plus is adding on second number carbon. What will happen in that case? Here you can see instead of CH I have written CH2, and on adjacent carbon positive ion will be there. So this is our positive ion. Now this is our first degree carbocation, and we know that 2 degree carbocation is more stable than 1 degree carbocation. So this intermediate is more stable. Now step 3. What will happen now? Wherever you have given the positive ion, just add OH on that carbon. So when this carbocation reacts with H2O, just add OH on the positively charged carbon. So this one was our more stable carbocation. It will give us major product. So this one is our main product, propane 2-ol. This is our main product, this is our minor product. You can see this one is our 1 degree carbocation. It will give us minor product, and H plus ion will be liberated. We'll get our catalyst back here. H plus means acid. We'll get our catalyst back here. So this was the mechanism of Markovnikov rule. Now the second method, to prepare alcohol from alkene. Again we are preparing alcohol only here from alkene. So second method is by hydroboration. Now this method is new. Here reagent is used, that is diboron, BH3 twice. It can be written as BH3 twice or B2H6, that is BH3 twice only. It can be written either BH3 twice or B2H6. Both are same, and the name is diboron. The name of this reagent is diboron. Now here we are going to react this part only, BH3 only. You have to write this B2H6 or BH3 twice, but in the reaction show this part only, BH3. Okay, now BH3 has some advantage here, that BH3 can break into 2 ions, that is H minus ion and BH2 plus ion. Generally hydrogen makes positive ion, H plus ion, but here one advantage is there of this diboron reagent, that it can make H minus ion. Okay, this one is special reagent. It can make H minus ion. So 2 ions will be formed, H minus ion, BH2 plus ion. Now look at the reaction. What will happen here? When alkene, this one is propene, again reacts with BH3, again apply Markovnikov rule, H minus ion it makes, and BH2 plus ion. Negative ion will add on carbon. This one is H minus, this one is BH2 plus. Negative ion will add on carbon that has less hydrogen. Now here you can see these 2 carbon. You have to observe these 2 carbon. This second number carbon is having less hydrogen, so H minus ion will add on this carbon, and this BH2 will add on this terminal carbon. So our product will be CH3 CH2 CH2 instead of this CH, you can see CH2 is there, then this CH2 and BH2. Okay, now what happens here? Again, another molecule of propane will react with this BH2. These two will react here. Now again same method is there. Just add this whole compound to this boron. So CH2, CH2, CH3 will be there. One hydrogen remains. Similarly, third molecule of alkene will react with boron. So it will give us BCH2, CH2, CH3 thrice. You can see this is first time, second time, third time. So it is trialkyl boron. Okay, this one is our step 1. It gives us trialkyl boron. This is step 1 of the reaction. Now step 2. What is step 2? So you have to react hydrogen peroxide here for oxidation. This one is our hydrogen peroxide for oxidation in presence of water and a base. In presence of water and base. Hydrogen peroxide, water and base. These three reagents you have to use. So what will it give? You can see boron has 3 alkyl groups here. So these 3 alkyl groups will leave boron and give OH, means alcohol group. This will break into 2 OH group. So one OH group is attached with alkyl group CH2, CH2, OH. Now one OH is remaining here, that will attach with boron. So it will give BOH thrice. Okay, so this one is hydroboration reaction. Now here one important thing is you have to note, in first step you can see, in this step when we react alkene with BH3 diboron, it follows Markovnikov rule. Okay, we have seen that it follows Markovnikov rule, but product you will see, you can see the product is our anti-Markovnikov product. This product is anti-Markovnikov product. So here I have written it follows Markovnikov rule in first step, but when we get product, the product is anti-Markovnikov product. Okay, that you have to note here. If the reason is asked, then you have to explain this mechanism, whole mechanism. Okay, so that's it for today. Thank you.